if you say base height and so on, it's still delta x and a bunch of heights. This time, however, delta x changes to from 2 to 5, so a total region of 3 divided into n chunks. Here's where things start to get kooky. Is this first x just a single 3 over n, or is there more to it than that? Yeah, you didn't start at 0, so that x is starting at 2, going over a 3 over n. It's f at 2 plus a 3 over n. And the next would be f at 2 plus 2 3 over n's, and so on, ending at f of 5, so that in the summation, I might see something a little more complicated. I'd still see the base of 3 over n, but that 3 over n is loaded because it doesn't mean it went from 0 to 3. 3 wide could have been a lot of different regions. It could have been 0 to 3, could have been 2 to 5. So this isn't enough to tell me these limits of integration. It just tells me the region's 3 wide, but it doesn't tell me where it started. You have to look in here to say, where did it start? So if I were writing the integral that's equivalent to this, I'd say, okay, I know it's 3 wide based on that, but the fact that it starts at 2 and is 3 wide means the limits go from 2 to 5. And then it's f of x dx. Now, let's practice that a little, shall we? So say I gave you this Riemann sum. And the question is often, what is this equivalent to? What is this like? Well, you should right away think it's like an integral. Now, what integral? It's an integral from, now, this tells you it's 3 wide, but it doesn't mean 0 to 3. What does it start at? It starts at 2 and it's 3 wide, so it goes 2 to 5. This tells you the function. This is f of 2 plus 3 over I n. So what is the function? X to the 5th. That integral express, or that summation crazy expression is equivalent to a more clean definite integral. You with me? All right. So try this one. What are the limits of integration? 1, 2, 5. Excellent. What's the function? Root x dx. Okay? Yes?
So for the first example, would it also work if you did 0 to 3 of 2 plus x to the 5th?
So that's a great question. Why not? How do you know that's not part of the function? And it's not 0 to 3 and 2 plus x to the 5th. Those are actually the same. And so those could be, one of those could be a different multiple choice. This is the more common. They don't want to get too funky at you. But that is a possibility. You're absolutely right. If you look graphically what that looks like, this is here. This is the same as shifted left 2 and 0 to 3. It would be the exact same chunk of graph, and therefore the same result. But yeah, it's a different way of thinking about it. I'm so glad you said that. Thank you. Okay, so try, so the point is there could be multiple answers, and I don't want to freak you out because this is hard enough anyway, but try and come up with a solution to any of these two, and then we'll move on. Do you agree with my first one? That's the definite integral from 0 to 4 of x squared. The second one's expanded form. They're not giving you summation notation, but still the same idea. The number outside is the delta x, so that indicates the region's too wide, but we still don't know if it's 0 to 2 or something else. Inside, it feels like it's just going by nothing else but 2 over n, 4 over n. So it feels like it is starting at 0 because I'm not seeing something like 2 plus 2 over n, which would indicate it's starting at 2. So it feels like it's starting at 2 and going to 0 and going to 2. Do you agree?
Yes.
What's the function? 3x. Yep. That's it. Okay? All right. Let's go the other way. Maybe do just 1 or 2 of these here. Let's start off with this x cubed one. It's easier. Now, say then they asked you to go the other way, and from this definite integral, write the Riemann sum. Start with the limit. An infinite number of rectangles of the sum. I typically leave off the indices, but it's going from I equal 1 to n. Don't sweat that too much. That's, I mean, part of the concept, but it's not. I doubt that would vary in the multiple choices, so don't worry about that so much. In here, I need a delta x and an f at point, right? So what's the delta x? 4 over n, okay? And the function is f at 0, starting at 0 and just going up 4 over n's. And so this would be something like what cubed? 4 over n I times cubed, right? All right, let's do one that's over here. Now let's go back to this one, which doesn't start at 0, so maybe a little harder. And let's go with the limit statement. The sum, what's the delta x? 3 over n. And the function is 3 blank squared. But what goes into the function each time? Think starting value plus changes. 2 plus 3 over n some number of times. Yeah? Okay, try this one on your own and then we'll move on. Please. Right? Okay, so you got your limit, you got your sigma, and 3 over n. The function's 2 over root something. What's the something? 1 plus 3 over n I times. All right, sounds good. Trapezoids, they don't do error bound on the AP test. It is on most college syllabi, so I teach it. And you need to know it, but it's not on the AP test, so you don't have to expect that. If equal subdivisions are used, then you can factor out the delta x, and it looks something like delta x over 2, and inside is f plus 2f plus 2f plus dot dot dot, ending at a single f on the outside, right? That can be used if there are equal subdivisions. If there are not equal subdivisions, so for example, if they gave you a table and it went from 0 to 2 to 3 to 10, then obviously these deltas aren't all the same, so you couldn't factor it out. There's not a common factor to be had. You have to do all separate base 1 plus base 2 times height divided by 2's and add them. I guess you could factor out the divided by 2 if you wanted to. I don't. But that whole idea of factoring out a delta and that 1, 2, 2 thing, that's out the window. That's not there anymore. Okay? All right. Also, trapezoids overestimate if what? If the curve is concave up. Right? Is that right? Draw a picture. Concave up. And that's different than rectangles, which is all about increasing or decreasing for left hand, right hand. Okay? I think that is good. There was one on that review that kicked my butt. The one that was this, I knew my answer wasn't right, but I could not figure out what I was doing wrong. That's hard. That goes to like a core historical math idea. a bit of a gotcha. No, you should do it. Think about it, okay? It's a challenge problem. All right, let's go to definite integrals and integration application, which is yeller.
Wait, when is this?
Let's do it today. Isn't this blue to do today?
You just gave that to me.
You guys got this Friday, yeah? And I believe I said no matter what, if you're dead, you're going to turn in a Tuesday. What? Really?
Yeah.
Wait, how
Was
does
I
this?
supposed to give you something? Why did I say that?
I don't know.
Maybe I got hit in the head. So the gold today, that's not my thing.
That makes you sad.
Gold today, blue tomorrow.
What gold?
The gold that most people should have already turned in. Review 3, gold is due today. Review 4, blue is due tomorrow. I think you're taking advantage of my 4.
No, I promise you.
This promise don't mean nothing. Just kidding. What do you want? What's your question? All right. 7th hour. All right, let's note it up. Yellow, are you ready? Can I ask you a question? You won't answer this because you probably. Is this nothing doing? I mean, is this reviewing helping at all?
Yes.
Oh, I don't want to waste your time. Okay. Okay. So here we go. The fundamental theorem of calculus. Because I'm a total nerd, I will sit around in the summer and just sit there thinking about the fundamental. I'm serious, 100% serious. Yes, nerd. And yes, I do have friends, by the way, and a wife, so take that. Okay? I did find a girl, nerd. Thank you. So anyway, there are a million ways to think about this, is my point. And this is the one that, to me, is my favorite. All right? So, it goes like this. Do you agree that this is true? The derivative equals the derivative.
Yes.
Boom. Right? Now that's a mixture of Newton and Leibniz notation. And this is why it's so cool. It uses both. We know that if you move this dx over, then now dy is f prime of x dx, which really represents twofold. This side is like a little rate of change, amount of change in y compared to amount of change in x times the amount of change in x. It gives you a dy. Now dy is a tiny change in y. When you calculate that, it represents a small delta y, which is to say a tiny, tiny change in y. Now if you then sum all those calculations, you get a total change in y. If you make lots of little bit of change, little bit of change, little bit of change, you add them all together, you get all the change, or the total change. Now in calculus then, when you sum many little changes, it gives you total change in the function. And I could say the total change in function then would be what it was at the end, take away what it was at the start. That's the change, is end minus start. Now all you need to do is throw a little limits of integration there to say, hey, this is the region over which I'm finding the change. And that's one of the ways to look at the fundamental theorem. It's an aggregation or a sum of tiny little changes. Please, this is the idea at the heart of the calculus, integrating, or at least the second part, integrating a rate of change gives amount of change. If you were to think of this in a velocity case, which is definitely how Newton thought about it, okay, I know that change in position over time is velocity, right? At the velocity, not v, right? Would you agree? And so dx then is, or change in position is rate times a small amount of time gives you change of position. If you then integrate that to aggregate all those changes, then overall, that's what's the total of all the little movements, all the little rate times times. And the total of all those little rate times represents how the position changed overall. Integrating a rate of change gives you an amount of change. That's the fundamental theorem applied to motion. All right? Now then, if we, oh shucks, I already had this here. Integrating a rate of change gives amount of change, not amount. Okay? If you want amount, then you have to consider two things. How much did it change and where did it start at? So start plus change, depending on what you're talking about, it might be f at 0 plus 0 to some x of the rate of change. I'll use a u in there to hold the place or dummy variable until the x comes to 3, right? Start plus change, right? Integrating gives amount of change. Initial plus integral gives you amount itself. Sometimes, however, rather than see the derivative in the integral, they actually write it this way. They would say if you let this be the function, well, you still would need to find the antiderivative of that, so we call that capital F. And this is the more common form of the fundamental theorem. But at the end of the day, you definitely need to understand that if you get a definite integral, it's a two-step process. How do you evaluate a definite integral? You first need the antiderivative. Then you evaluate it at the upper limit minus the lower limit. Okay, you need the antiderivative. Sometimes people get, they get confused and they don't actually even integrate. Oh, I was supposed to pass this around. Hey, can you give me a rough idea of whether you'll be here Friday, Saturday, or Sunday? And I'm not going to hold you to this. If you want to switch over, that's fine. Okay. Definite integral has area positive and negative x. So here's the deal. If you have an area above, and really the integral means sums of rectangles, if f of x is positive, then isn't the integral, or the sum of all those rectangles, going to be positive? And if the area is negative, if f of x is negative, then the integral, we know, should be negative. If you had a little mixture of above and below, then I guess it would mean comparing the two areas and which one's bigger. All right? Now, that's assuming you go left to right. If you went from 2 to negative 2, in this case, going from 2 to negative 2 is a negative change in x. So when you go backwards in limits, you'll actually get the opposite result of what if you had gone left to right, as left to right. You with me? Okay, so understanding check. Say I gave you this graph, and I said, what is this? What's the sign of this? Would that be positive or negative? Positive, what? Yeah, the f are negative, the delta x's are negative, so overall it would be a positive outcome. You with me? Okay. Geometry to evaluate a definite integral, you should definitely be aware that if you get a circle or a constant line which involves a rectangle or a triangle, then by all means use geometry. They don't say, oh, he didn't show calculus. If they give you a figure like that, they're expecting you to consider geometry and possibly use it. Are you with me? Rules for the definite integral. You know that switching the limits, we said that switching the limits gives you the opposite result. That's one we already talked about. You should definitely use additivity. For example, if you had 0 to 2 of f plus 2 to 4 of f, isn't that equal to 0 to 4 of f, or vice versa? So there's additivity of integrals. Please keep in mind, we talked about products and sums yesterday, so I don't know if we need to talk about that. Is there another one I'm missing? One second. Good point. It does happen once in a while, so it's good to talk about. Even functions have symmetry about the y-axis. So if you said the integral from negative to 2 to 2 of f, where f is even, then it's equivalent to 2 times the area from 0 to 2, right? Whereas if you had odd, there's symmetry about the origin. If I said negative 2 to 2 of f is where f is odd, then what does that have to be? It's 0, okay. Negative equals 0, I don't think. Okay. All right, thank you. You're right. That's right. Okay. Functions defined as an integral. If I say f is this graph, whatever, this is very common problem 2, 4. And if I say g is an integral defined function, maybe 0 to x under, actually, let's do 2. It's harder. Sometimes they start you at 0, but sometimes they throw you a curveball, start you in the middle of the graph, and you got to be able to deal with that. Dummy variable there. Okay. Tell me, is g of 0 positive or negative? Now, if you're not sure, then put it in and say, well, that's the same as this. And looking at that, thinking rectangles, is f positive or negative? F is positive, but dt, or the delta, the change, the deltas are negative, so this is negative. You could also think of this as the same as, isn't this the opposite as going 0 to 2? And that's the opposite of a positive area, so it's, again, negative, yeah? Are you with me? And then there's obviously all the possibilities of how do their derivatives relate at all levels. Make sure you communicate your reasoning first. In fact, if you get this on a free response question, would you please, at the start of the paper, just say, you know what? Right at the top, I'm going to write G prime is F, and G double is F prime. And I'll probably say it again in all the parts, but get it on the paper right away, okay? Just put it there. Okay. Using an initial 2 ways. There are 2 ways to use an initial condition. I want you to be fluent with both. If you're going to be a good calculus student, you should be able to use, it's like using both feet as a soccer player. If you're going to be any good, you need to be able to do both. Okay? So, say I gave you, this is the derivative, and there's an initial condition. Never assume that 0 always zeroes out. That's dangerous thinking. So, one way to find the function is to actually integrate, get a plus c, and find the plus c with the initial. If you were to do that, then you would say f is the antiderivative of f prime. You would integrate. What's the antiderivative there? 3 halves x squared plus 2e to the x plus c. And then you could use the initial condition. 2 goes in for f. 0 plus 2e to the 0 plus c. And so what is c? Is this 0 or 1 or 2? 1 times 2 or 2. 2 minus 2 is 0. So the function is 3 halves x squared plus 2e to the x plus no c, right? That's one way. Another is by using a definite integral approach. Think start plus change, right? So f is the start, f at 0, plus the change from 0 up to any old point of the derivative. Now, if you write x there, then you really would use a dummy variable in here to kind of hold the place until x comes in later. So maybe use u or t, I don't care. You with me? All right, now if you did that, you could then substitute, what's f at 0? 2. What's the antiderivative? 3 halves u squared plus 2e to the u from 0 to x. Then evaluate the integral. When x goes in, don't you get 3 halves x squared plus 2e to the x? And when 0 goes in, thanks, don't you get 0 plus 2e to the 0 or 2? So you can see then, the other ways the 2 drops out and you get that same function. Either way, right? Right? Right. Okay. Fundamental theorem of calculus part 2 is the idea that the derivative and the antiderivative are inverses. So if you take the derivative of the antiderivative, it's just the function. Now that's the pretty case of it's just an x going in. You also practice some nasty cases where you're taking the derivative, but up here is this crazy function. In those cases, you use the chain rule. You plug that u into the function, but then you have to remember to take the derivative of the inside. And average value. Average value, please read carefully. Average is such a loaded word in calculus. It could mean 2 totally different approaches. Are you talking average value or average rate of change? It's possibly even you could be doing both, and they're actually equivalent, all right? So read carefully. If they say average value, and they ask you to interpret it, it's the average value of whatever's here. Don't overthink it. If I say, hey, what does this mean? And that is the average velocity. It's the average value of whatever's in the integral, and velocity is in the integral. So it's the average velocity, okay? Mean value theorem for integrals just means there is an x value that makes the average value. I know, in the book you had to do a lot of those problems right next to each other and you're differentiating. And that doesn't happen very much on the AP test, but just to make sure you're clear, if I talk mean value theorem, no descriptor, then it's applied the mean value theorem for derivatives. And that's the idea that if I have a curve like this, then there is an average rate of change, and there's got to be a place where the instantaneous rate of change is the same. And when they say find the c guaranteed by the mean value theorem, you're saying at what x value is that tangent slope the same? You with me? If they say mean value theorem for integrals, then they're talking more like, where's the average value? So wouldn't you agree that the average y value is somewhere in here so that the area above and the area below would knock each other out, right? But then, so that's f at c, the average y value. The c is the place on the curve where that average value is made. Do you follow? Okay, last but not least, motion interpretation. You are often asked to do interpretations of integrals. What is the integral of velocity mean? Position. Okay, it's position or change of position. Change of position, which we also call displacement. I love change of position. If you like change of position, use it. They actually prefer that because they're not physics people, they're calculus people. But displacement is also good. What if velocity is negative? Velocity is always positive. And isn't this also distance? Okay. What about the second one down, going down? What about the integration of the speed, which is making all movements positive? I don't care about direction. Take away the sign. What is it? That's distance. Okay. What about that guy? That third one down. Average velocity. What about the fourth one down? Average speed. It's what's in the integral? It's an average value idea, but average value of what? Well, that time speed. What about the third one? It's the velocity at time 0 plus the change in velocity gives you what? Start velocity plus change in velocity is velocity at time t. Start plus rate of change, integrating a rate of change gives you an amount of change. That's velocity at time t. This guy up here in the second column, what is it? Average position. Yep. What about the next one now? Average acceleration. That one. Velocity. Change in velocity. Change in velocity. Hey, when they ask you to interpret, they'll say interpret with correct units. Remember what it is with units, when it is with units. So you would say this is the change in velocity in meters per second. Per second. No, change in velocity. So change, yeah, not in front of it. Change in velocity. So wouldn't change in velocity be meters per second? Sorry. From time 1 to time 2 seconds or something. Okay? How about this? Starting position plus change in position is position at time t. And this one, this is often served up as a multiple choice answer. It is starting position plus distance, which gives you nothing. It means nothing. It has no meaning. All right. If I said, for example, hey, you started at 2 on the number line and went a total distance of 17 units, what does that tell you? Nothing. I have no idea which way I went, 17 units which way. It tells you nothing. Okay? All right. That is that. I got through all this. I'm caught up. What a great day. Do you have any questions? No? Excellent. You have a question on this?
Yeah.
Oh, I will say this. That yellow, I hesitate to tell you this, but you're not dumb, so I guess you'll see it. I put the free response rubrics on the back. Please don't say, oh, I just get myself started. That's not how you're going to have the AP test. You're not going to have the key on the back page, I assure you, to get you started. So just do it all the way through, try and make connections, and only use that at the end to make it work. Do not use it to get you started. Okay? No.
No, but rip them all this small. That's the only way to get it, guys.
All right. So we decided gold is due today, blue is due tomorrow, yellow by Friday.
Wait, gold? Yeah.
Gold is due today.
So gold is
No, it's not. Gold is due today. Gold is due today, right?
no gold. You said gold is
Why are you looking away?
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I'll be walking around if you have questions.
I have
This one,
End of the year celebration will be next Friday, May 3rd.
This one is a doozy because of the
Yeah,
square
Friday,
root.
Social District's sponsoring a screen-free day to encourage you to connect in person with a positive friend and mentor who increase our strength. Participants who give up their phones for the school day on Friday will receive a treat along with the clarity and genuine connection that come when we unplug. Find the new school player on Friday in order to take part.
Not everyone has unlimited funds like Gatsby, but donate your old required read books to the library so that we can save some cash. All conditions and votes accepted.
Ever wish you could print from your Chromebook instead of using the print station in the library? It's coming next week. However, there will be no printing available on the morning of Wednesday, May 8th.
Students interested in participating in a robotics competition next fall should attend an informational meeting Friday, May 3rd in the computer lab at E202. Both middle school and high school students are welcome.
Girls Mentoring will have their end of the year celebration on Friday, May 3rd. Please check in with your teachers and then join us at the cafeteria for pizza and fun.
Save the date. Junior high play Beware the Jabberwock on Thursday. Show begins at 7 p.m. Tickets are $8 at the door.
All students, do you want to win a free 7 hours of learning time on run an ice food truck, available to buy treats, bring candy, freshly food, by Friday, and put them in your grade level box at the free office or by the cafeteria. The grade level donation with a free 7th hour on May 10th. All donations go to the Best Academic Network for adults with developmental disabilities. Teachers, if you continue to donate more than your staff, you'll win free prize.
Find when it's time.
Anyone who has not done their AP read book
I mean, I couldn't get the first one. My problem was I forgot the pay. So philosophy is 3 squared minus 12 is 8 plus 20, right? And if I want the minimum velocity, I want to know where the derivative. Oh. I need to know what a V prime is. So the height is great. I
That's all you're not.
so I see my first page behind but then you need to know. Nice job. Have a great day.
Should I go outside and try to
Have a wonderful